Okay, and then what I'm going to do is I'm going to go ahead and clear my outputs, and we'll work through this. Okay, so today I wanted to talk about flow control. So, as you code and write functions, or even if you're not writing a function, you just need for things to operate and run, or you have a loop or whatever it might be, we need to be able to control what happens, and that often depends on if statements and things like that. So we'll look at flow control, and then after we look at flow control, um, I want to introduce or talk about lists. Lists are a very important data structure in Python, and they have some nice features and certain methods associated with lists. So we kind of want to make sure we cover that. I've also posted homework from DataCamp for this week. These are there are 5 chapters, 3 from the Introduction to Python course and 2 from the Data Types course. And these will cover just some key ideas in Python. And again, each thing is just a chapter. You don't have to complete the entire course. So I think in the Intro to Python, I think there's like one more chapter afterwards. And, it's up to you if you want to complete it, but it's not required as part of the homework for this week here. Okay, let's go ahead and take a look. Our basic conditional tool is the if statement, and we can pair it with the else if, the elif, and an else. And the way statements in Python work is we have to use indentation, and there's no kind of curly brace to associate lines together or group them together. We use indentation. And then to kind of end the if statement, we use a colon. Okay, so you don't need to use any kind of parentheses. You use a colon to end the conditional statement. And when there's no longer indentation, that's when it realizes the line is done. Okay. So the if, the else if, and the else have to be on the same level of indentation. So if you kind of change any of this stuff, you're going to get these indentation errors. All right, so here's a very simple example. We're going to just assign the value -3 to the name x. And we're going to just do a quick comparison. We're going to just check, is x equal to 0? If it is, we will print out the value of x, and the text is 0. We'll do an else if, another conditional check. If x is greater than 0, then we'll print out x and say it's positive. Otherwise, we will print out the last thing and we'll say x must be negative. Okay, so I think this is fairly straightforward. So when we plug in x equal to 3, it's going to output -3 must be negative. And I could change something else. I can do x is equal to 3, and I can execute this, and it'll say 3 is positive. If I put in 0, I get that. If I put in any kind of value, we get this code seems to be working just fine. Okay. Over here, one thing to note about this, okay, is that I've got, if x is greater than 0, it's going to print x is positive. And it's important to note that as soon as this registers as true, okay, as soon as this conditional statement is true, it's going to skip everything else. It only looks at the else if, or the else statements if and only if the if statement is false. Okay, so if this is false, then it's going to evaluate the next one, and if that's false, then it will evaluate this one. So in this case, if I have x equal to 100, it's going to say x is greater than 0, and then it's going to print x is positive. And this thing of being x greater than 3, there is no value of x that would evaluate where this is going to be true, and this is false, but this is true. Okay, there's no way to kind of do that, right? So if I put in anything else here, I'll get, you know, x is negative or something. Here I'm going to get x is positive. If I put in 3, we'll get 3 is positive 4. There's no situation where this statement will ever get executed, because it's only, Python's only going to look at this when the this statement is false. You can nest conditional statements inside other statements. So here I can do this. I can do x is equal to 5, and then I can say if 0 is less than x, then you can do another conditional. If x is less than 10, and then we'll say, you know, print x is a positive single-digit number. You know, I guess technically, you know, there's decimal values, right? So, you know, if I plug in 10, this is not going to print anything out. If I put in 0, it's not going to print anything out. But if I put in 4, you know, this evaluates to true. Now, nested conditionals can be difficult to read, so I would generally avoid it. We can use an and statement. We can see if 0 is less than x and x is less than 10. Okay. You know, x is still 4 here, and this will evaluate correctly. And Python also supports doing conditions like this. And so we often see this in math. 0 is less than x is less than 10. And that also works in Python. Not all languages support this kind of conditional statement, but Python does support this. So you know, you can do use and statements, or you can, at least for this kind of is x within a certain interval, you can do it as such here. All right. We have recursion. Okay, recursion is the idea of calling a function inside of itself. So you write a function, and within that function, you call the function itself. Okay, and this is how you can have something kind of do something recursively. So an example of like a recursive function is the factorial function. So you can say 4 factorial is the same thing as 4 times 3 factorial. And 3 factorial is the same as 3 times 2 factorial. And 2 factorial is 2 times 1 factorial, and so on and so forth, right? And basically you're going to kind of recursively call something. Anytime you have a recursive function, you need to have a base case so that it doesn't run on forever. Okay, so here I have a very simple recursive function where we're going to put in an integer, and if that integer reaches 0, then it's going to print out blast off. That's going to be our base case. Otherwise, what we're going to do is we're going to print out the value of n, and then we're going to subtract 1 from n, and we will call the same function countdown on the new value of n minus 1. Okay, so if we start off with n equal to, say, 3, then you know, it hasn't reached the base case yet, so we're going to print out 3, and then we're going to call countdown on 2, right? So then we call countdown on 2, and in countdown on 2, it hasn't reached the base case, and so it's going to print 2, and then it's going to call countdown on 1, and then we try it out. We haven't reached the base case. It's going to print down 1, then we're going to call countdown on 0, and when it reaches countdown on 0, then it's reached the base case. It's going to print blast off, and then it returns the function. There's nothing to return. It returns none. Okay, and then it climbs back up to the 1, and so it kind of it returns all of these things. All of them return none. So we're going to get, you know, basically 3, 2, 1, and then it reaches the base case of blast off here. So that's recursion. Anytime you have the name of a function called from inside the function itself. That's a recursive function. And so, recursion is always kind of this idea of, taking a big thing, making it a little bit smaller, and then, doing the same thing, but just on a smaller version until you reach, the base case. All right. So here we'll try out another simple example. We'll print out a function n times here. So here we're going to take just some arbitrary string, and then we're going to say n. And what this is going to do is going to print out that string s, and we'll take n and reduce 1 from it. And then we just keep doing until we reach the base case where n is 0. And in that case, we're going to return none, which will, basically exit out the function. So if I do this and I say print hello 3 times, we're going to get hello, hello, hello. I can say do it 30 times and it executes. I can say do it once and it works. And then if I do 0, then it returns none. Okay, because it just starts off at the base case. Factorial function also is an example of a recursive thing. So again, the base case for a factorial function, factorial of 0, is going to be 1. Okay, so that's, if we said return 0 here, then all factorials will end up in 0. But yeah, 0 factorial is 1. And so, I can, if we reach that, we'll return 1. Otherwise, the factorial function is going to return the value n times factorial n minus 1. Okay. And so I can do factorial 4, and we get 4 times 3 times 2 times 1 is 24. Factorial 5 will give me 120. What would happen if instead of return, I do print? Will this work? What would happen here? Okay, this is not going to work, okay? Because here, we're asking it to print n times factorial n minus 1, okay? And in this case, if I plug in 0, all right, let's just go straight to the base case, okay? Factorial 0 prints out 1, but does this return anything, okay? If I say x is equal to factorial 0, and I ask what is x, x is none, right? So if I say print whatever x is, it's going to tell me that, x is the none thing, right? So what it's working with here when I do factorial, say 1 here, so again, factorial 0, it's going to print out 1, but if I try plugging in factorial 1 here, okay, what's going to happen is it wants to print n, which is currently 1, times the result of factorial 0. What is the result of factorial 0? Factorial 0 will print out 1, but it doesn't return anything. So it's going to do n times none. And then that's the error that we're getting. You can't do n times none. Okay. So if I do 1 times none here, I'm going to get the exact same error. Unsupported operand the star of int times none type, right? So when here we're trying to do 1 times none, that's the error that I'm getting. So we don't want to do print. We want to make sure we use the correct function return here. So if I do return here, factorial 0 will work correctly, and it returns, you can see it returns 1 and not just prints, right? So if I do print, you'll notice I don't have an output. I don't have a square output, right? I just have, it shows 1 on the screen, but there's no square bracket here, so that it's not an output. So if I do return here, okay, now I get a returned value. I still have print written here, so it's not going to work, okay? So factorial 1 works, but then when I try factorial 2, I get an error because, again, it's trying to do a print here. So again, we want to make sure you use, return. So that's important. Okay, so factorial 2 works, 3, so on and so forth. Okay, factorial 5. So make sure you use return and not print anytime you have some kind of recursive function where you want to kind of use that result in the next thing. Okay, let me go ahead. Did I give you your first quiz answer yet? I don't think so, right? First view quiz answer is E. E is our first view quiz answer. If you do want to repeat something, technically you can use recursion for everything, but recursion is kind of slow and computationally expensive, so it's often not recommended for a lot of things. It's also hard to debug recursion things. Sometimes it can be. So in other cases, we can do a for loop. Okay, so in for loop, you have something that's iterable, like a list, like a range of values or series of values. And then it's basically going to repeat the code inside the for loop, okay, for every element in that iterable. Okay, so here I have a list with the numbers 5, 7, 2, and 1. And what I'm going to do is I'm going to execute these code chunks that are associated with the for loops. I have 4 basically X in this list values. Okay, so for each element, and we're going to call the element X. So the first iteration, X is the value 5. We're going to print out 5. And then I'm going to add X and update the value of Y. So I have Y plus equals X. This is the same thing as writing Y is equal to Y plus X. And then we're going to print out the running sum is Y. Okay, so here I do this, and first iteration I'm going to print out 5, running sum is 5, and then we're going to go to the next value 7, and the running sum will be Y plus which is 5 plus 7. We're going to get 12, and we're going to add 2, and so that's what we get. Okay, we get 5, running sum is 5, 7, running sum is 12, 2, running sum is 14, 1, running sum is 15, and that's a for loop. Okay. Strings are also iterables. Okay, iterables in that every character. So if you say for A in this string, each character is an element. So the first iteration of the loop, that's going to do A is going to be U. Next iteration is going to be C. Next iteration is L. Next iteration is A. Next iteration is the space. And for each iteration, what we're going to do is we're going to take that character A, we're going to make it uppercase, and then we're going to tack on an exclamation point. So now it feels like we're, I guess, cheering or chanting. And then, so we have U, C, L, A, and then I guess exclamation point. This is when you just throw up your arms without saying anything, I guess. And then we have this, right? So not quite the 8 clap, but a little bit, right? Okay, so we have that. The range object, is how we can kind of produce basically an iterable of integers. Okay, kind of a sequence of numbers, and so we can do range. So if you do range 10, this will give you an iterable that is length 10, and it will be the values 0 through 9. So again, everything in Python starts off at 0. So if you call for 10 values starting at 0, you're going to get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and it's kind of like writing 0:9 in R, and it basically creates this kind of range of indices, length 10, starting at 0. The general format, if you want different kind of sequences, you can specify a start, an end, and a step size. But kind of the most frequent is just doing like range 10. And the result of a range 10 is a range object. Okay, so if you do range 10, it's going to say, all right, we're going to start at 0 and end 10. Here, whenever you see the end here, it goes up to but doesn't include the end. So basically, starting at 0, ending up to, but not including a 9 here. So if I just do, say for I in range 10, and all we're going to do is we're going to print the value I here. We're going to just print out 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Here, the end argument is a space, which just says, hey, after you print, don't do a new line, but put a space here, okay? And so we get this, right? If I remove the end argument, then everything appears on its own line, which is fine, but here I want to do that. I mean, you can replace this with, whatever thing you want, okay? But here we have a 9, and technically we have a space after the 9 as well. So here's range 5, 10. And you can just kind of see, I can take that range object and I can put it inside a list just so we can see the actual values. We don't have to run this print loop every single time. I could just say, hey, make a list out of this thing. So what are we going to get? We're going to get 5, 6, 7, 8, 9, but not including the value 10. Okay, so that's what we get, 5, 6, 7, 8, 9. Here, if I do range 0, 20, 2, we're going to start off at 0. Our step size. So remember, the arguments inside range are start, end, and step size. And then again, let's see. Let's show contextual help. Show contextual help. So this is range, and it tells you, okay, if you just have one thing, you get range stop. That's the range object. If you do range start, stop, and then maybe an optional step, you'll get a range object. And here's basically stuff like that. Okay, so let's do 0, 20, and 2. So it'll go 0, 2, 4, 6, 8, and it will go and it will end at 18. Okay, that's what we have here. Now here's something. If I do 0, 21, it will go up to, but not including 21. So this is, this feels a little bit weird. We're doing step size 2, but I'm intentionally ending at 21. So it's going to go 0, 2, 4, 6, 8. Goes up to 18 and then 20. It's going to end at 20, not including 21. If you try doing something like this, 20.1, okay, it doesn't like it. All right, it says float object cannot be interpreted as an integer. So it says you bad. It doesn't like that. Okay, so obviously you would never write this out yourself, but you might encounter something like this where you want to create a range object based off of, other variables, right? So you might, somewhere in your code, you might say, let's make a range out of, going from 0 to X, step size 2 or something like that, right? And then, and X is the result of, some kind of calculation. We do 10 divided by, or I don't know, 100 divided by 5, okay? And you feel like, oh, okay, well, X is going to be 20, and then let's do this. But remember, anytime you do division, you get a float, right? And so you got to take this, and then you got to basically make it an integer. Okay, and then now it works. Okay, but if you did something where you have like this mathematical operation that results in a float and you try to use that, okay, then you get these you get this error there, right? So just things to, obviously no one's going to do this on purpose. But I mean, I shouldn't say no one, but it'd be foolish to do this on purpose. But you end up encountering stuff like this, right? And again, a lot of times the error messages in Python are helpful. So always look at the Python error message and say, hey, this is the line that's causing the thing. And it says float object can't be interpreted as an integer. That's often going to give you a clue as to what went wrong. All right. So that, again, one of the most important skills that you can learn as a programmer or coder or whatever you want to call yourself whenever you're writing code is being able to understand the error messages that pop up. Okay, let's see. Here, if you specify a negative step size, then it goes backwards. Okay. And if I don't specify a negative step size and I have my start at 10 and my end at 5, okay, then it, gives me back nothing, right? Oh, that's actually what I have right here, right? So if I do 10, 5 and I don't specify a negative value, we'll get no values in the output there. Okay, let me go ahead and give you your second view quiz answer. All right, we have a while loop. A while loop is very similar to for loops, except it runs on a conditional statement. And so basically it's going to run whatever code is inside there as long as this conditional statement is true. When the conditional statement is false, then the loop stops running. So, so here I have I equals 0, and then I have while I is less than 10, print out I, and then increment I, right? Add 1 to I and keep going. So this will keep going until it reaches 9. Okay, now here's the question. What is the value of I here? So I just ran this loop. So I started off at 0. It printed 0, and then it added 1 to I, and it kept going. Then I was 1, and then I was 2, and it keeps going, and it quits after it prints out the 9, it adds 1, I becomes 10, and then it evaluates the statement. While I is less than 10, I is no longer less than 10, so now it's a false, so it quits out, okay? And so if I ask, what is the value of I? It tells me, yeah, the value of I is 10. And that's why the loop stopped running. The loop stopped running there, okay? If I change this to while I is less than or equal to 10, what's going to happen? Okay, well, now it will output the value 10, and then I will stop when it's 11. Okay, so it will output 10, and then now I stops when I reaches 11 there. Okay. We have keywords break, continue. Okay, break statements. The break statement is stops the loop. Okay, stops the loop entirely, and then the continue statement skips the remainder of the current loop. All right, and goes to the next iteration. Okay, I'm going to just respond to this message in the chat privately. Okay. All right, so here I've got for n in range 20. So what is n in range 20? It's going to start off at 0. It's going to go 0, 1, 2, 3, all the way up to 19 and quit at 19. Okay, that's going to be the last thing. And here we're going to do if n mod 2 is equal to 0. So basically, modular division basically is asking, is the remainder after you divide by 2 equal to 0? So is it divisible by 2? So it's going to start off at 0. And it's going to say, well, 0 is divisible by 2 evenly, and our mod there. So it's going to skip, right? It's going to hit continue. And when it hits continue, it skips the rest of the code in the loop. So it never actually hits this thing. And then it goes to 1. With 1, this thing is false, so it doesn't evaluate the continue, and it's going to print 1 out. Then it goes to 2. When n is 2, this is true. So it hits the continue, and it skips the rest of the loop. So we're going to basically just get all of the odd numbers 1 through 19 when we print when we run this thing. All right, here is an example of creating a Fibonacci sequence. Here I have while true. Anytime you have a while true, that means it's going to run forever. Okay, it's going to run forever until it encounters a break statement. It encounters a break statement. So I'm going to start off, and we're going to use tuple unpacking here. I'm going to have AB is equal to 0, 1. Okay, 0 and 1. And then we're going to say, okay, take B and then make that your new A, and then take A plus B and make that your new B. Okay, and then we're going to just keep doing this until A has reached a value greater than 100. And when it does that, then we're going to break. All right, we start off with an empty list, and I haven't taught you list operations yet, but that will come just later in today's lecture. We're going to append whatever this value A is to the list. We're just going to basically take the value of A and insert it to my list. Okay, and so So we're going to get the Fibonacci sequence. So it's going to start off with 0 and 1. And then for that value 1, B is going to get assigned to A. And then 0 plus 1 gets assigned to B. So now I have 1 and 1 here. This is not true, so it's not evaluated, but we're going to append 1 to our list. Then we get, A and B are currently 1 and 1. A is going to get the value 1 here, and then we're going to do 1 and 1 is 2, and then B gets the value 2, and then so on and so forth, all right? And then we get this, right? So this is one way to generate Fibonacci sequence. Okay, Boolean expressions, I think we're all familiar with this, right? You get trues and falses. So you do, is 5 equal to 5? Yep. 5 equal to 6? Nope. 5 not equal to 6? That's true. Is 5 greater than 6? No. 5 less than 6. So these are just kind of checks here. We have greater than or equal, less than or equal. If you do something like this, I have the string 5, and is that equal to 5? We say, oh no, that's not the case, right? Because this is a string. This is these two things aren't equal. When you have strings, you can compare them, and here it's asking is it before the other in the alphabet? It's a little bit weird though. Okay, all of the uppercase letters come before all of the lowercase letters. So we're saying, is capital A before B in the alphabet? That's true. Capital A comes before little a. Little a in the sequence. Capital Z comes before little a. Little a comes before Z. But if I say, hey, what about A coming before capital Z? Okay, that's going to be false. Little a coming before capital Z. And then, there's like all kinds of weird stuff, right? Like, what about the number 4 and the number 2? Okay. And then you also get like weird things like, is 10, less than 2? This ends up being true because it sees the 1. It's kind of like asking, is the word, if you think of 1 being like B, right? So it's kind of like comparing BE, is that does that come before the letter C, right? And that's going to be true because the B comes before C, and the 1 comes before the 2, and we're used to this, but this feels funny. So just I don't know if you should be using greater than or less than to compare strings, but Python allows it, and that's what you have. Okay, so anyway, you get these logical values, or not logical, Boolean values. Logical and Boolean values are like interchangeable, but in R they're called logical, in Python they're called Boolean. So we have these Boolean values, all right, true and false, and we have these logical operators, and or not. We write these in lowercase, and this behaves exactly as we expect. True and true is true, true and false is false, but true or false is true. Not true is false, not false is true. False or not false, what is that? That's going to be true. Okay, true and not false. True and not false. You have to think about this, right? Not false is true. True and true is true. So true and not false is true. X mod y equals 0 is it divisible by y? So we can say n is 6, n is divisible by 2, and n divisible by 3. Is that true? That is true. What about n equal to 8? N divisible by 2 is 0. Is it divisible by 2? And is n divisible by 3? That's not true. Okay. But what is it divisible by 2 or 3? That is true. One thing about writing functions, and so this is just a little bit of advice here. I advise against going straight into writing the function. So first, write code in the global environment to achieve the desired task. And then once you are able to do that, then you encapsulate your code into a function. Don't start writing the function, because if you write your code inside a function and it doesn't work, it's really hard to debug. So just see if you can get it to work in the first place. So let's say we had this thing where it was like you're giving instructions to a pen, and you want to draw a square. So you're going to say something like, go forward 100 pixels, then turn left 90 degrees. Go forward 100 pixels, turn left 90 degrees, go forward 100 pixels, turn left 90 degrees, go forward 100 pixels, and then turn left 90 degrees. And then, you can see like, okay, yeah, that will draw out a square, right? So this is just some imaginary circumstance here. And we can say, all right, well, let's try this. And basically, I want to just do go forward 100 and turn left 90 degrees. And I want to repeat myself 4 times. So I can do for I in range 4. And then we do go forward 100, turn left 90. And so this will do it for I is 0, I is 1, I is 2, I is 3. I don't even have to use I here, right? So if I do I range 4, it's just going to do this thing 4 times, even though I'm not actually using the letter I anywhere inside my function or inside my code here. And then we're going to define this as my function draw square. Okay, so I define the function draw square, and we have this. If we want to then generalize to say, allowing us to change the length of the side of the square, I can put in an argument, say for length, okay? And then we'll say go forward the length, right? And then, and so that works. Now, what if we wanted to draw different kind of polygons, right? Now let's say, okay, so if I wanted to do something, say for a pentagon, what is the angle that we need to go? Okay, we would actually the angle that we would turn, because this is the if you're the internal angles add up inside a pentagon add up to 540, and then if you kind of do the external complementary angles or right complementary angles add up to 180, is that right? Yeah, I'm confused. Okay, well, anyway, just whatever it is. Complementary angles. Oh, complementary angles add up to 90. Supplementary angles add up to 180. Okay, so so if you kind of take the supplementary angles of a pentagon, so the internal angles add up to 540, and if you take the supplementary angles, they add up to for basically any of these shapes, they add up to 360. Okay, because you want to kind of face back in the original direction. So we're gonna turn left, our angle here. So we're gonna do 360 over 5. We get 72 degrees, and this is what we have here. Okay, and so we can do this. If you wanted to do a hexagon, you would get this. And so if you wanted to generalize to just any kind of n-sided polygon, you could do something like this. This is a little bit of an aside regarding like writing a function, but in some of your exercises, I ask you to write functions. And I would always kind of just say, start off by doing this. Don't even write define function just yet. Just make sure you can get it to work in the first place. Make sure you can, if you're going to use a loop, make sure you can get your loop working in the first place. And then once you get it working, then you put it inside a function to encapsulate it. And then you start replacing any kind of hard-coded values with variables. And you try to work it out that way. Okay, let's talk about lists. So a list in Python is basically this ordered data structure, and you can mix data types. So here I'm mixing strings and floats, and we're going to call this our family, where we have Liz and Emma, mom and dad, and we also have these numbers. Okay, and so I could say, hey, what is this? And that's this list. You can have a list of lists, and so notice inside here I have an outer list, and within the list I have 4 smaller lists. The smaller lists each are of length 2, and so I can say, hey, what's that? And now I have a list of lists. To subset the list, you can use square brackets. square bracket 0 will give us the very first element. So on fam, the first element is the string Liz. On fam2, this list is a length, has a length of 4, all right? And so fam2 index 0 is the first element, which is a list of length 2. And so if I want to get Liz, the string Liz here, out of the fam2 list, I would have to do fam2 square bracket 0, which will be this thing, and then square bracket 0 again to get basically this out of this here, okay? You can also put in a negative number, and that will count backwards from the end. So this is index position -1 is 1.89. Over here, if I do index position -1, it's going to give me the list with dad and 1.89 in it. And, you know, similar to this, I can do -1, -1, and we get basically this value inside this thing, right? So we select this thing first, and then we're getting this thing. So you can kind of reference any of these values in here. Okay, let me give you your final UQuiz answer. Okay, we can slice a list. So basically subsetting a list, but you want to select multiple things. And you can think of slicing happening at the commas in a list. So here, if this is my list here, and I say slice from 1 to 3, you can basically think of it happening at comma 1 and comma 3. So we're going to go from comma 1 to comma 3, and we're going to get out these two values, 1.7 and Emma. Okay, that's what we get. So if you do 1:2 here, we're going to just get this element right here, 1.73. Okay, and then if you just slice at 1, okay, the first comma here, you're going to get back nothing. Oh, I'm sorry. No, that's wrong. Square bracket 1 basically selects index position 1, okay? But then if you slice 1:1, then you get back nothing. So sorry, the colon is for slicing. So doing 1:1 basically will give you back nothing. Whereas if you do square bracket 1, then you're saying I want the value at index position 1, right? It's 0 index position 0, index position 1 is 1.73. But if you do a colon, it says I want to slice from this location to this location. Okay, so what will 0:2 do? All right, so basically you have think of a comma at position 0, and then comma at position 2 will give us Liz in the 1.73. 6 through 8, okay, 1, 2, 3, 4, 5, 6. 6, this is our 6th comma, here's our 7th comma. I guess there would be an invisible 8th comma after the 1.89. So we're going to get dad in 1.89. 2: is starting at the 2nd comma and then taking everything after. 4 is starting at the beginning, going up to the 4th column. So we're going to get everything from Liz to 1.68. Okay, and then just doing a colon here will give us basic 0, nothing: nothing will give us the entire list. Okay. So that's what you have there. If you do a square bracket and you don't put anything in there, then you get back an error. It says you're not allowed to do that. What about -5? Here we can count backwards. Okay, -5, 1, 2, 3, 4, 5 to -2. I think we're going to get this. Okay, so counting backwards. Yeah, -5. We're starting right before 1.68 to -2. We're going to end at 1.71. Okay, what about fam2 1:3? What are we going to get there? Here's comma 1, here's comma 3. So we're going to get a list with these two lists inside of it. Now, Now, if we do this, I can do element 0, and then I want to go from 0 to 1. So this is going to extract out Emma. Okay. Lists themselves are mutable, which means they can change. That you can we have methods that will modify the list. So here I have fam. I'm going to print fam out. I'm going to make a copy, not a copy, I'm sorry. I'm going to put another name called second, and second is going to point to the same object as fam. And what I'm going to do is I'm going to change the 0 element, Liz, I'm going to change it to sister. And then I say print out what second is. Second is going to have sister in the first position, index 0. But second and fam are pointing to the exact same object in memory. So when I print out fam here, it has also changed, right? So this very first command creates a list in memory called fam, or associated with the name fam, and Liz is the first element. And then I say second points to the same object. So I have two names. Fam points to the object, second points to the same object. And then with second, 0, sister, I'm changing this thing. And so second points to this thing. And when I say print second, it gets this out. But that name fam points to the exact same thing. And so, so we get that. Here is a small difference. Here I'm going to make a copy. Fam square bracket colon square bracket creates a copy of the list. So fam creates an object. Now when I say second is fam square bracket colon square bracket, I get a copy. I take this thing and I'm duplicating it. And so I'm going to change the value of the first element to sister and second here. And this thing up here is not affected. So here I can see fam, it starts off with Liz. After modifying second, I get sister over here. But when I say print out fam, it still says Liz. So, so it is not modified because it's a copy. Okay, you could do the same kind of thing. You can call fam.copy, and that will also create a copy. It's kind of the same thing as this. And similarly, I can say, you know, change element index 1 to 1.65. And so that thing has changed here, whereas, you know, fam itself has not been changed because it's a copy. So if I say, hey, what is fam? It looks like that, right? You can also get a copy by calling, say if fam is a list, you can call list on fam, and list2 itself is a copy. So these are just different ways to create copies. So you can do, you can subset all the elements will create a copy. You can do the object.copy will create a copy. And then in this case, because fam is a list, taking a list and putting fam inside of it will create a new list that's a copy. Okay. You can also use list slicing in conjunction to changing values. So here is fam, and elements 1 through 3, the slice will be 1.73 to Emma, and I can say, hey, replace that with 1.8 and Jenny. And so now those two values, 1.73 and Emma, are now 1.8 and Jenny. Okay, I'm running out of time here. We have a couple methods. We've seen the copy method. You can also use the append. Append just takes whatever element you want it, and it modifies it, just tacks it on at the end. So here I'm going to do fam and me, and it tacks on me at the end here. Okay, you can also do the same kind of thing by using a plus operator. All right, but one thing, yeah, so you can kind of take another list, combine it, add it, and here notice that I'm saving the result. I'm doing fam plus 1.8 and saving that back to fam. Okay, I can do dot append again, and then I'm further adding more stuff here. Okay, I can append a bunch of elements here. Okay, I have a list here, but notice this thing is going to append it as just one entry there. Okay, so everything, I've run out of space, so it formats it in vertical thing. But now I have these are things here, but this last thing, which is an entire list, gets appended as a single element within there. Okay, so if you wanted to have it all together, you'd probably use the plus operator. And if you do that, then the last 4 elements here don't get added as just one thing. They just they get added individually. But notice I didn't save it. I didn't say fam equals fam plus all of this stuff. So fam just remains the original. Okay, I have a example of a copy versus decopy. I'm going to kind of skip that. Here I have insert and extend. And these are just kind of things where it's like insert into comma position 4, insert the word Joe, right? So at the 4th comma. So this is where you're going to insert it. Okay. So we have that. And I'm sorry, I'm going over time. So if you got to go, you got to go. But just a couple more minutes here. I just have these 4 cells to show. Okay. If you try to insert multiple elements, like I've got a list with Joe and 2.0 here, it's going to insert the list as a list right there. Okay. If you try to say, hey, I want to do, if you provided multiple arguments here, it says you can't do that. Okay. You can only insert one thing at a time. You can do extend. You can do extend, but this is going to add things just to the end here. So it will do Joe and 2.0. So if you do want to have something like Joe 2.0 added into here, but not added as a list, you can use list slicing in conjunction with assignment. So I'm going to do fam 4:4. So this is a time where doing 4:4 where you're actually selecting nothing. Basically, in the list position, we are looking at this 4th comma here. What we're going to do is we're going to insert Joe and 2.0 to insert that into the 4th position in the list there. Okay, sorry for going a few minutes over, but we'll wrap it up here, and you know, just kind of look over these examples that we kind of went through them quickly in the end, but look over them and just make sure you understand them. All right, we'll go ahead and end here for today. Have a great rest of your day, and we will see you on Friday.